Why is post-processing important for prototyped robot parts? Imagine building a robot and discovering that its parts look rough, don't fit well, or aren't strong enough. That's where post-processing steps in to save the day. When creating robot parts through methods like three-dimensional printing or other quick fabrication techniques, the initial pieces often have surface imperfections, support structures, or slight size deviations. These issues can make the parts less reliable or even unusable in a real robot. Post-processing helps fix these problems, turning rough prototypes into functional components ready for testing or deployment. First, the surface quality of printed or molded parts is usually rough with visible layer lines and leftover support material. Smoothing these surfaces makes the parts look better and reduces friction, which is important for moving parts or contact surfaces. For example, sanding or chemical smoothing can make a part slide more easily or prevent damage from rough edges. Improving appearance also makes prototypes look more professional when showing clients or team members. Next, mechanical strength is often lower in raw printed parts. Post-processing techniques like heat treatment or chemical smoothing can improve the durability and strength of these parts. This is key because robotic components need to withstand forces, impacts, and repeated movements. If a part isn't strong enough, it could break during operation, causing delays or safety issues. Another reason is dimensional accuracy. When parts are printed, slight deviations from the intended size can happen due to the printing process. Post-processing allows for fine-tuning these dimensions. For example, filing or sanding can help parts fit perfectly with other components, ensuring the robot moves smoothly and functions correctly. Tight tolerances are especially important in robotic joints or gear assemblies. Support structures are often necessary for complex shapes during printing. Removing these supports carefully is vital to prevent damage. Post-processing helps cleanly remove supports without harming the part, which is essential for proper function and assembly. It also helps in achieving the desired shape and surface finish. Customizing parts is another benefit. After initial fabrication, you might want to add coatings to improve grip or resistance to wear. Slight shape modifications can also be made to optimize a part's performance. Post-processing gives engineers the flexibility to adapt parts for specific tasks or environments. Testing and iteration are easier with high-quality parts. When prototypes are well finished, they better representing the final product. This allows engineers to test how the parts perform in real conditions and make improvements faster. It reduces the number of reprints needed, saving time and money. Safety and usability are also improved through post-processing. Smoothing rough surfaces and removing sharp edges make handling safer. Strengthening parts ensures they don't break unexpectedly, which could cause injuries or damage. In the world of robotics learning and career development, knowing how to post-process parts is a valuable skill. It bridges the gap between designing and building real, working robots. Good post-processing techniques help produce reliable prototypes quickly, which speeds up learning and project development. It also helps control costs by reducing waste and rework. While post-processing takes extra time and effort, automation is making it easier. Machines can now sand, polish, or clean parts automatically, increasing productivity and safety. This means faster turnaround times and more consistent results. Overall, post-processing is a key step in turning rough prototypes into reliable, ready-to-use robot parts. It ensures the parts are strong, accurate, and safe, making it an essential skill for anyone involved in building and developing robots.